Hey everybody, my name is Scott, and today we're going to solve the daily temperatures problem on LeetCode. This is kind of a cool problem. Let's talk about the problem definition really quick. We're given a list of temperatures, and we need to output a list that for each day in the input tells how many days you would have to wait until a warmer temperature. If there is no future day where there's a warmer temperature, we output 0. Let's look at the example given here. Here's the temperatures for the given days, and time goes to the right here, as time always goes to the right. So here's 73. Note, we go from 73 to 74. That's not 0 days, that's considered 1 day. So in our output we put 1 day. 74, 75 is greater, just another 1 day. 1 day here. 75, we have to go 1, 2, 3, 4 days to get to 76. So 4. So on and so forth. See 76 here, output 0, nothing after 76 is warmer. 73, output 0, it's the last in the list, nothing after it. So we can take from right there, our last element's always going to be 0, there's nothing greater than the last element. It doesn't wrap around or anything. It'd be pretty cool if time wrapped around though. Alright, so the first thing that would jump out at you when you see this problem is there's a naive big O n square solution, which is easy, right? We would loop through this list twice, and for each element, just find the next greater element, pop it in here. Works, but it's not fast enough, so we need to do better than that. There's no special algorithm. When I was thinking about this problem, I started thinking hash table, binary search tree, but our goal is to get our time complexity down to big O of n. Thinking about those things, none of those things really helped. So if we're a little clever about the way we do this, we can get our runtime down to big O of n. And here's how we'll do it. We're going to start at the end of the list when we're observing this list. So we'll start here at the end. And what we're going to do is keep track of the temperature on a day and the number of days that it takes to get to its next warmer temperature. And we're going to do that using a stack. So for our stack, we keep a stack, and the first element we'll push onto the stack will be 73 temperature and 0 days. So we push that onto the stack. And then as we make our way back through this temperatures list, what we'll do is look at what's on the stack. If the temperature at the top of the stack is less than our current temperature, then what we'll do is we will pop that element off of the stack and forget about it. But the way we'll keep track of it is we will add its days to this element's days. Okay? So what that's going to do for us is, as we're finding elements that are less than us to our right in time, we can just forget about them. We don't have to process them again. We will just keep track of those days in this element, and then when we actually do find one on the stack that's greater than us, we will just leave that element on the stack, because that greater temperature might be a greater temperature for something further back in the list as well. So we'll leave that one on there. But the key observation is that, let's see if we can pick out a good example here in this input. So let's say we look at 71, and we're trying to find 71's next greater element. Well, we look at 69, and we say, what's not greater than it? Let's say 69 is at the top of our stack. 69 is not greater than it, so we pop 69 off. We don't need to consider 69 for any of these elements to find their greater element, right? Because we know that 69 is not greater than 71, so for each of these elements, the number of days that it's going to take to get to their next greater element will be whatever 71's number of days is, right? We don't have to worry about this interim bit. So we would say 71, get rid of 69, we know it's less than it. We found 72, okay? So we'll store in 71 2 days, and we'll put 71 and 2 days on top of the stack. So when we come back here to use 75, we can say, is 71 greater than me? Well, no, but I know 71 took 2 days to get to its next greatest. So we'll do a +2 for 75 days, 75's days. And we don't, 69 is not here anymore. We don't even have to think about it. We've already computed that with 71. And then we'll go on and we'll find 72, and similarly, you know, that's how we will go about eliminating these things and making sure we only compute them once. So that's a big thing, is when you find things that are less than you to your right, you don't need to process them later. Just store the number of days in that element, and then as you find things further back in time, you can just consider the number of days that it took to find this element's next greater. So let's implement it. So we're going to be putting int pairs on top of the stack. So I'm going to use a custom made class here called int pair. And it's going to have a couple of public attributes, which will be called days and temp. Here, days represents the number of days that it took for this temperature to get to its next greater temperature. Temp, obviously just the temp. Probably picked up on that. Let's write the constructor. Have it take in a days and a temp. Set up the days and temperature. So once we have this little class set up, it's going to be very helpful for our implementation. Let's move it outside of this function because that makes no sense whatsoever. There we go. And let's get into writing our function. So we've got to return an integer array of days. Going to be the same length as temperatures. Let's go ahead and return him at the bottom here, just to make sure we don't forget. So let's handle a base case. Actually, from what I found when I was solving this problem earlier, is it's guaranteed that temperatures won't be empty, but we're just going to cover all our bases here. So if the length is 0, we just return days. Not an edge case that the problem says we need to handle, but we handle it just in case because we're very thorough like that. So let's set up our stack. We're going to have a stack of int pairs. Just call it stack. And this is where we will store all that information for the temperature and how long it took to get to its next greater temperature. So let's make one for the last day, because we know this information and it's a good example. Well, how many days does it take to get to the last day's next greater temperature? 0. Talked about that, right? There's nothing that'll be greater than it after it. And its temperature at the end. So that's how we're going to set up these int pairs. Let's push him onto the stack. And let's set up our return value. So that's just saying that the last element that we're always going to return is 0. Alright, so let's loop through these temperatures. I'm going to start at length -2, because we've already considered the last element. I is going to be greater or equal to 0, and we're going to decrement I each time. Let's pull the current temperature out of the array. I'm going to have so many syntax errors because I'm going to misspell temperatures about 7 or 8 times. And the current days here is going to be the number of days it takes this element to get to its next greater, which we're going to start at 1. Alright, now here's basically the meat of the algorithm. Stack's not empty, gotta make sure. And stack.peak, so we take a look at what's on the stack without removing it. .temp less than or equal to the current temp. So what is this Boolean expression doing? Making sure the stack's not empty. And if the pair of integers on the top of the stack, if the temperature is less than or equal to the current temperature, then that means we have to keep looking in time, right? We have to keep going to the right looking for a greater temperature. So if the days are equal to 0, then what does that mean? Let's throw the peak in here. If the element on the top of the stack's days is equal to 0, what must that mean? That means there is no element to the right of that element that has a greater temperature. So if we're in here, this means that not only does this element not have anything that's greater than it, but it's less than our current temperature. So we just stop looking. So let's just take it off, set our days to 0, and stop looking for this element. So our current days will also be 0 because we're greater than this element, and it has nothing that's greater than it. I'm going to take that element off the stack because we don't need to consider it anymore, and we're going to break beak. We're going to break out of this loop. So that just handles that edge case right there. Now, if this has not happened, then what does that mean? We're in here. We have an element at the top of the stack, and its temperature is less than or equal to the current temperature. That means we need to keep looking to the right in time, which means our days are increasing. Our days are increasing. So our current days is going to increase by the number of days it took this element to find its next greater. And at the same time, we're going to take it off the top of the stack. And the last thing we need to do in this for loop is set up a new int pair. Of our current days and our current temp. Push that onto the stack. And then set up our output. So our output is this days array. It's current days. That should do it. See how it looks. Compile error. Line 3, identifier expected. Heh, of course. We need to tell Java what data types our fields are. That one's on me, Java. Alright, finished. Got the right answer. Let's submit it and see how it looks. So algorithmically we're correct. Let's see if we're actually fast enough. And accepted. So we are. Good deal. So the big takeaway here is if you're faced with a problem where you're dealing with things where you need to find a next greater and you're kind of dealing with time or something like that, stack is often a good idea, because what the stack did for us is we were a little tricky in the way we manipulated it, and it saved us time in terms of the asymptotic complexity of our algorithm. So by being a little tricky with the way we use our stack, we avoided recomputing a lot of unnecessary information. So that's it for this one. It was a pretty fun little problem, and hopefully you enjoy it. We'll see you next time.